Okay, so we're going to focus on talking about casting today. And in order to do this, we've got to, I guess, talk about making sure we have an understanding of the difference between references and values. Other things that I need to mention are, we'll still work from this workshop app. There's a branch that asks you to work from. So this is will work from here. When you're on the branches, just choose from this one. There'll be some instructions here. But let's talk about casting. So first of all, we have to make sure we have an understanding of the difference between a reference and a value. So when you create a variable in Java, and this is similar to a number of languages, sometimes you are holding the value itself, and sometimes you're holding a reference to the value. All right, and it's important to make this distinction. So when we think of holding a value, think of the primitive data types. So there are, oh dear, I think there's 8 in Java, essentially all the kind of number data types. And when you create a variable, these are holding the value directly. Whereas if you are creating pretty much any kind of object, you are holding a reference to that object. You're not holding the value itself. And this distinction is important because well, let's maybe have a look at an example. Let's model this. Let's say, for example, we have an array, and let's say our array is going to be an array of numbers, and let's be specific. Let's say it's going to be an array of integers. So this array in Java, we hold, when we store this in a variable, we hold a reference to it. So let's say, for example, we have an array of 1, 2, and 3. And let's store this in a variable called, I guess let's call it nums. All right. So this type would be some kind of integer array. And the variable name nums is a reference to it. It doesn't hold the value directly. So if we were to create multiple variables holding the same reference, they all point to the same reference. They don't point to individual values. All right. So say, for example, let's say we have another variable, nums2 and nums3, and they both point to that original reference, even though we have 1, 2, and 3 variables, they all point to the same reference. All right. And this is important to remember because sometimes this will trick you out, especially in the Java exam. They'll try and get you to trick you out by thinking, is it a reference or is it a value? And so making sure we understand the difference is going to be important, because if you were to change one of these items in the array, this is a value, it would change for the array, and all these variables, nums, nums2, nums3, point to the one reference. And so it would update for all of them. All right. So a reference doesn't hold the value itself. The reference just holds, the variable just holds a reference to it. And let's see this in action. So let's create, maybe it's a bit bigger so we can, all right, you don't like those because you're J-shell and you're very basic, fine. Okay. So let's create an integer array and give it, as we said, 1, 2, 3. And let's also give the same integer array nums2, and let's point it to that reference. And let's do the same thing with a third variable. So you might think in your head that you're creating 3 separate variables with individual arrays, but you're not. They're all pointing to the same reference. All right. So if you were to update, let's say let's get from the first array and let's update this to be let's say value 4. You can have a look. That original array, cool. We've updated it. The first element is 4, but because they all hold a reference to the same array, each other variable is also updated. All right, it's not even updated. It's just pointing to that original reference we've updated. Right. So a reference is different to a value itself. A reference is just essentially a pointer to a memory address that says this is where the value is. Whereas like a number, like an integer, holds the value itself. All right. So why are we talking about this? Well, the difference between references and values are important. It's not the focus of this session, but it's some context, because when we think about casting, we're going to be thinking about the references to objects that we hold. So let's imagine an example where we have a hierarchy. So we've done a little bit of inheritance on Tuesday, and so let's imagine we have I think the example I've used in the repository is a base class or a superclass called animal, and a derived class or a subclass called dog. And dog extends animal. Okay, so we've created a relationship between these two classes. And when we create an instance of them, we're holding a reference to them. All right, we don't actually hold the value itself. And so when we try and change the type by casting it, and we're not actually changing the value itself, and this is important to remember, which is why I started off on the left-hand side here talking about references and values. So when we think about casting, and we have to remember that we're dealing with references, not values, which is different to type conversion, when we're actually converting one type into another. And this is when you convert some of those primitive types, you can end up losing information about those values. We're not going to worry about type conversion. We're just going to think about casting, and this is the focus today. So casting involves references because we're using instances of classes. So we can only cast when there's a relationship between two classes. And so we can form it ourselves by extending classes, or we can use the object hierarchy in any class that we're given. Java is an object-oriented language, so any class instance that we use already extends the object class. And so we can have a look at some of those classes, and we can cast upwards. We have 2 ways we can cast. So we think about this relationship here. We have our parent class, or you'll either hear this be called a parent class, a superclass, a base class. These are all different ways to express the relationship between classes. And we have equally, if we call this a parent class, we call this a child class, or a subclass, or even a derived class. So when we think about the relationship between these, because dog extends animal, we can either cast up or cast down. All right, and we refer to this as upcasting or downcasting. The idea is, when I talk about casting, I'm talking about the type for our value. All right, whether it's going to be an animal or whether it's going to be a dog. So when I create an instance of a dog, let's say, for example, yeah, let me write it out here. When I create an instance of a dog, so we're going to create an instance of a dog, and I have to give it a type. So you might imagine normally we would do something like this: give it a name, and we have our type, we've got our variable name, and we've got our instance. So the available types that you can declare is anything here, and we can do what we call an implicit upcast, anything that's up the parent chain. So because dog extends animal, I could also declare this to be an animal. So this would be a valid cast for our dog. We're saying, yes, we're going to create an instance of dog, but we're going to store it, the reference to it, as an animal. All right, and this is an implicit upcast. You don't need to specify what type it is by doing something like, and you might have seen this before, this would also work, but it's unnecessary to do something like and say it needs to be an animal. So this part here is the cast, but when you upcast, especially up the parent chain, you can just do it implicitly. All right, so this is redundant. This is extra information that's not needed, because when we upcast, it's quite straightforward to upcast. When you upcast, almost think of it like a file directory, as that every child knows what its parent is. So when you upcast, it's usually fairly straightforward. Now there are some rules to upcasting. When you upcast, you are using the reference, but you're not changing the value, but you're limiting what methods are available. So, for example, if you had, let's say, instance method here, let's call it instance 1 as a method. This is pseudocode, all right? You also override it in your subclass. But you also have an additional method here, instance method 2. When you upcast an instance of dog to be a type animal, you are limiting the available methods. And so you are unable to call this method. This is no longer available to you, because you're always going to be referring to instance methods from when you upcast dog to animal from the animal. So you're always going to be invoking from the animal class. However, if the instance method is overridden, then you actually end up invoking this method. All right. So if you have both instance methods in your superclass and subclass, the subclass method gets invoked. All right. So rule 1 for upcasting is you're always limited to the available methods in the parent class up here. Right? Anything that's only defined in the subclass is no longer available. Rule number 2 is if both methods are available, then the subclass overrides it. All right. Rule number 3 is static methods belong to the class. All right. So static methods are always going to be belonging to the class. And so if you upcast, if you have the same static method, static on and static one, then this one will always be invoked. All right. So instance methods are overridden, but static aren't. So when we upcast, it's important to remember these rules because this Java exam will test them. All right. And so upcasting is important for us to be able to go through and practice. Upcasting is much safer. We will never, you only essentially narrow down the available methods. So that's why we don't need to explicitly cast. You can always implicit cast when you upcast to get back to like the base, the superclass here. Now, downcasting is a little bit more tricky. When we downcast, the rule for downcasting is the instance that you're downcasting already has to have knowledge that it was once that thing. So if we have a look in this example here, we go from our instance and we are upcasting it. If we start off with an animal and we try and downcast it to a dog, it will throw an error because it didn't have knowledge that it was ever an instance. And this is coming back to the point of references and values. The value hasn't changed. So the value has always been a new instance of animal. So I guess, let me write it down here. If we were to try doing something like change color. I can't spell animal. If I create an animal and then try and downcast it, and let's say, for example, I want now this to be an instance of dog. Something like this. And so by this expression here, I'm saying I want to now cast this as a dog, my instance of animal. This will throw an error because this value here hasn't changed. It's still an instance of animal, and we can't make it now an instance of dog. All right. So it's much, you've got to be careful. It's a little bit trickier when we downcast. So usually the process of downcasting is it should already have been a dog at some point. Then maybe it was upcast, and then we can downcast it again. So if we go through and change it, so this would be not correct. This would throw an error, and specifically throw in Java, it will throw some kind of casting error. Usually I think it's a class cast exception. So the proper way will be to do something like we would have, we can maybe use animal and create an instance of dog, new dog. So I'm storing this variable, an instance of dog, but I've upcast it implicitly to animal, and then I could downcast it. Because it already was a dog, and this is the value. So if it was already an instance of dog, it holds that value. The reference, the animal type, is applied to it, and it limits the available methods we can call on it. And there are some rules and what methods will get invoked that I've already mentioned, and we'll practice in just a second. But because it already was an instance of dog, we can then downcast it again because that value hasn't changed. All right. So knowing the difference between a value and a reference is going to be useful here to remember that difference. So another, I guess, something to help with this is like, what's the point of casting? Another like question here, sometimes it's useful to think about this in terms of polymorphism. And I think we talked a little bit about this earlier on the course when we're going through some of our object-oriented design stuff at the beginning of the course. Polymorphism. Polymorphism is the idea that we don't really care so much about type, we just care about behavior. Like not what it is, but what it does. So we should be able to have different kinds of objects, different kinds of types, and yet still have like a common interface, the same method. And so you might imagine being able to have some kind of method that takes in different types, like dogs and cats and different kinds of animals, and then they all have like the same method, and that they can get invoked. We don't have to worry about what type it is. Is it a dog or is it a cat? Because they're all going to be of a base class animal. We should be able to work with them. And so casting will help us with that. So if we can upcast back to a base type, and we can override those methods, then we can still get different behavior, but from the same parent class. Because this rule here of if you override it in the subclass, we can still invoke that method, even though it's the type of animal. So we can get a bunch of objects of one type, but have different behavior. And so this will help us in some situations when we need to take advantage of that. Different objects of different types, we upcast them to the same type, yet they still have different behavior. So there's an example in this workshop that will help you think about this, just to try and give you some context to why this would be useful. For the exam, we just got to know the rules. All right. When can we upcast? What methods will get invoked when we upcast? The difference between instance methods and static methods. And then what are the dangers with downcasting and how do we do it? All right. As I said before, we can only cast if there's a relationship between these objects. And we can either use ones that we created ourselves, or we can use like the object hierarchy to take advantage of it. Another way to think about this, or some words that you might hear before, is upcasting as narrowing. So we're always going to be limiting the available methods that we can call, because we're going to from an instance or from a derived class back up the chain. All right. So you'll always also hear this as being called narrowing, whereas downcasting is widening. There might be more methods on the derived classes, subclasses that we can now invoke. Okay, so for today's sort of exercises, I want everyone to work from the casting branch in the same workshop app that we were doing earlier, thinking about interfaces and classes, inheritance and abstract classes. So when you check this out, make sure you fetch all the local changes. Just git fetch all to get all the local changes, and check out this new branch, casting. Don't look at the casting solution branch until after the Q&A at the end. Just focus on the casting branch. So check it out. And then to run tests, you can run all the tests, or if you want just to run a specific set of tests, you can run them by the class name. That'll help reduce some of the noise because there's all the tests that we did previously. And so you can just run this set of tests. And in addition, if you don't want to keep running them, you can just run them continuously. And this will trigger like on save, like we were doing some of our earlier work using some of the hot reload capability in Jasmine or React Jest stuff that we're doing. This might be useful. So what the intention is to start with this test and start running them and seeing the failures and resolving them step by step like last time. But let's have a look at the examples. So we're going to start off in this package casting, and let's start off the test. The test is the best thing to have a look at. There's one test, and this is where we're going to start. So what I want you to do is work your way through this. There's a set of classes here that we're going to slowly implement. And your first task is just to get these two tests to pass. The relationship between the animal and dog. These are just simply straightforward assertions on making sure the methods are returning the right things. All right. So you can comment everything else out if you want to, just to focus on these two tests. These two tests should give you the sort of foundation to then continue understanding the rest of this relationship. So have a think about understanding each of these methods. This is, just remember, this is a static method up here because it's the class itself, and the same with this one. And get these two tests to pass. After that, then think about each successive test. So read the class, the test name, think about what's happening, and replace the question marks with the right string value. All right. So according to the rules, you have to think about which method gets invoked, either the superclass or the subclass, and then what would be the value. All right. Once you've got these working, you should be able to make a hypothesis, write it down, run the test, and then see whether you're correct. And then, so this is testing the superclass methods. This is testing the subclass if it's overridden. Again, toggle this one. Again, this is testing that rule that says it limits the methods available. So anything in the derived class is not available. So you can run it just to check for yourself. This will test the improper downcast. So if you try and cast something that downwards that doesn't have prior knowledge that it was that instance, so the value is not already an instance of that dog type, it will throw an error. This is how you would do a proper downcast. And so making sure that you know what values each of these methods will be after, first of all, when you create the upcast, and then when you do the downcast, how those things change. Once you've done all those tests, there's another test here just to think about that polymorphic behavior. So read through this, and then your objective here is to implement everything in this new class called AgeFinder, and then making sure that you replace these question marks with the right values. All right. So first step is just the simple, straightforward assertions here, then thinking about the rules of the upcast and downcast. And then once that's done, do this last bit about polymorphic behavior. Now take your time through it. If you get confused, just use tech help or Java questions, whatever you want, on Discord, and then we'll gather back at about 11 o'clock. I think exactly 11 to go through this. All right. Does that make sense? Cool. Any questions you want to ask before you begin? Cool. Awesome. All right. Have fun, enjoy, and then be back here at 11. Otherwise, ask questions on Discord. See you then.